Falcon 9 was named after the famous Millennium Falcon from Star Wars, the 9 referring to its 9 Merlin engines on the first stage, and their job is to accelerate the vehicle through the Earth's atmosphere into various orbits. The two-stage rocket stands 70 meters tall. That makes it 14 meters taller than the highest side of the Leaning Tower of Pisa in Italy. Starting from the bottom, we have the first stage, that's referred to as the booster. It makes up about 60% of the entire length of the Falcon 9 vehicle. Above the first stage, we have our black carbon fiber inner stage. It's got that distinct color from the unpainted thermal protection system on the surface. This structure connects the first and second stages and houses our pneumatic pushers that are used during stage separation in flight, as well as the Merlin vacuum or MVAC engine on the second stage. Now, the white portion of Falcon 9 above that black inner stage is the second stage. After the first and second stages separate about 2.5 minutes into the flight, that second stage will ignite its Merlin vacuum engine and carry the Starlink payload into its destined orbit. Now, above the second stage is our payload fairing. That's the nose cone at the very top of the rocket. It's protecting the Starlink satellites until we get to space. About 3 minutes into the flight, once we've exited most of the Earth's atmosphere, we'll jettison those fairing halves and attempt to retrieve them once they return to planet Earth. We want to jettison those fairing halves as soon as we can because the weight of the fairing does decrease second stage performance. So once we're through the atmosphere, we don't need them on the vehicle anymore. Falcon 9 uses 2 propellants, a refined form of kerosene called RP1, or Rocket Propellant 1, as its fuel, and then liquid oxygen, or LOX, as its oxidizer. The liquid oxygen is chilled well below its boiling point, so it has a much larger mass to volume ratio at that lower temperature, and that means we can load more of it onto the rocket. In addition to these 2 propellants, we also use a chemical called TTAB, that's triethyl aluminum and triethyl borane, as an ignition source. So the combustion of the Rocket Propellant 1 and liquid oxygen is what makes the rocket go, but it's the TTAB that ignites that mixture to kick off the combustion reactions.